Imagine you're standing outside on a calm night when the sky begins to twist. Stars bend. The horizon ripples. And then, in the distance, you see it. A perfect circle of darkness swallowing the light around it. It is a black hole, and Earth has begun to fall in. What happens next will be unlike anything you can imagine. What is a black hole? A black hole is not a hole in space. It is space itself collapsing under the weight of gravity. When a massive star dies, its core compresses until all its mass is packed into an infinitely dense point called a singularity. The region around it, where gravity is so strong that nothing can escape, is called the event horizon. Once you cross it, there is no return. Not even light can get out. Black holes can be as small as a city or billions of times larger than the sun. They warp space, distort time, and form some of the most mysterious structures in the universe. Now imagine Earth caught in their path. The first signs, long before we reached the black hole itself, we would know something was wrong. Space around us would start to bend. The stars would appear to stretch and twist as their light curved around the black hole's gravity. Tides on Earth would grow stronger and stronger. The oceans would rise and fall violently. Earthquakes would increase as the planet's crust responded to the growing pull. The black hole would not even have to touch us to cause chaos. Its gravity alone would begin tearing our planet apart from millions of kilometers away. The pull of the abyss as Earth drew closer, the black hole's tidal forces would intensify. The side of Earth facing it would experience a much stronger pull than the far side. This difference would stretch the planet like taffy. The process is known as spaghettification. Mountains would crumble. Continents would crack. Oceans would rise into walls of vapor. The atmosphere would spiral upward, glowing from friction as it escaped into space. Every second would bring us closer to destruction. The final orbit, at some point, Earth would enter a death orbit. It would circle the black hole faster and faster, each rotation taking only minutes or even seconds. From space, it would look hauntingly beautiful. The planet would be surrounded by streams of glowing gas and plasma pulled from its surface. Those gases would form an accretion disk around the black hole. This disk would heat to millions of degrees, shining brighter than any star in the sky. For a brief moment, Earth would become part of the most brilliant and violent light show in the universe. What we would see from Earth, if anyone were still alive to witness it, the sky would look alien. The stars behind the black hole would appear warped into circles of light called Einstein rings. The sun would distort and multiply as its light curved around the gravitational field. As we approached the event horizon, light would begin to stretch. Colors would shift toward red. Then everything would fade into darkness. At that point, even time itself would begin to break down. The end of time. Einstein's theory of general relativity tells us that gravity slows time. Near a black hole, that effect becomes extreme. From a distant observer's perspective, Earth would appear to slow down as it approached the event horizon. It would never seem to cross it. Instead, the planet would freeze in time, its image fading and reddening until it disappeared completely. But for those falling in, time would seem normal. Seconds would pass as usual, though the rest of the universe outside would appear to speed up infinitely. In the final moments, you might see the entire future of the cosmos flash before your eyes. Inside the event horizon, once the planet crossed the event horizon, there would be no escape. All paths lead inward. Light, matter, and time itself are dragged toward the singularity. Inside, the concept of direction no longer makes sense. Space and time switch roles. The future points inward, and all matter moves toward one point of infinite density. Earth, along with everything it contained, would be stretched thinner than atoms, then compressed into the singularity. In less than a second, our entire planet would cease to exist. Could anything survive? It sounds impossible, but some theories suggest that not all information is lost. According to quantum physics, information cannot be destroyed. The data that makes up Earth's atoms, its people, its history, might still exist on the event horizon, encoded as quantum information. This idea is called the holographic principle. It suggests that everything falling into a black hole is recorded in a two-dimensional layer at its edge. If true, then Earth's story would never truly vanish. It would be written into the black hole's surface, forever etched into the memory of the cosmos. The view from afar, for any civilization observing from far away, the destruction of Earth would look different. They would never see the planet fall in. Instead, they would see it slow down, dim, and fade. The light from Earth would become weaker and redder until it disappeared entirely. To them, Earth would appear frozen at the edge of the event horizon for eternity, a ghost image trapped in space-time. In reality, the planet would already be gone, crushed beyond recognition inside the darkness. What happens next once Earth has been absorbed? The black hole would grow slightly larger. Its gravity would increase, and its event horizon would expand by an amount equal to the mass of our planet. That may sound like a lot, but for a stellar mass or supermassive black hole, Earth's mass is tiny. The black hole would barely notice the meal. It would continue to drift through space, silent and unstoppable, as if nothing had happened. For the universe, the loss of one planet would mean nothing. But for us, it would mean the end of everything we have ever known. Could we escape if we had enough warning? Humanity might try to flee. We could send ships to other star systems, carrying the knowledge and life of Earth. But traveling at even a fraction of the speed of light would take centuries. If the black hole were already close, escape would be impossible. The gravitational pull would affect every spacecraft, bending their trajectories back toward doom. The only hope would be distance, and even that might not be enough if the black hole is massive enough to trap light itself. A journey into the unknown. What if, somehow, you could survive falling in? Some theories suggest that beyond the singularity, there might be another universe, a mirror cosmos connected through a wormhole. You would fall endlessly, crossing a point where space and time reverse. What we call a black hole on one side might be a white hole on the other, a region where matter and energy burst outward instead of in. No one knows if such a passage could exist. The laws of physics break down inside black holes. Yet some physicists believe that black holes might be gateways to other realities, or even the seeds of new universes. The physics of destruction. Let's look at what would happen to the planet in scientific terms. As Earth approached, tidal forces would increase by trillions of times. The crust would shatter, the core would liquefy, and the atmosphere would be stripped away. Gravity would pull atoms apart. Molecules would stretch into long chains of plasma. Eventually, even subatomic particles would lose their identity. Energy, mass, and information would become one, part of the swirling chaos near the singularity. At that point, the concept of Earth would no longer exist. Only energy and curvature would remain. The beauty in destruction. It sounds horrifying, yet there is strange beauty in this process. A black hole is not evil or alive. It is a natural result of physics, the universe folding in on itself. If we could somehow observe the fall of a planet into one, it would be breathtaking. The light from the accretion disk would curve around the event horizon, forming a glowing halo that bends reality itself. The last image of Earth would be a shimmering sphere of light, spiraling into infinity. Then, silence. Could life continue somewhere else? Even if Earth were lost, life in the universe would continue. Other planets, other stars, and other galaxies would still shine. Somewhere, intelligent beings might look at our vanished solar system and wonder what happened. Maybe they would detect the faint radiation of the black hole that consumed us, a final whisper of our existence. In that sense, no world ever disappears completely. It leaves traces, echoes, and energy that ripple through time forever. The cosmic perspective. Thinking about Earth falling into a black hole is frightening, but it also reveals something profound. It reminds us how fragile our planet is, and how precious stability really is. The same laws of gravity that can destroy worlds also hold them together. The same forces that end life also create it. The universe is not random chaos. It is a cycle of birth, death, and transformation. Every collapse gives rise to something new. A thought experiment. Imagine, for a moment, that everything falling into the black hole is not lost but reborn. Perhaps the singularity is not the end but the beginning, a point where matter and energy reset into new patterns. In that case, when Earth falls in, it might help create another universe. A new cosmos could blossom from our destruction. Somewhere else, new stars could shine, and maybe one of them would have a planet like ours. If so, then the end of Earth would not be the end of life, but a continuation in another form. If Earth ever fell into a black hole, it would be one of the most spectacular endings imaginable. Mountains would rise and fall, oceans would vaporize, and the very fabric of space-time would fold around us. Yet even in that destruction, there would be meaning. Because everything in the universe is connected, the birth of stars, the collapse of worlds, the rise of consciousness. We are part of that endless story. The same physics that could destroy us also created us. So if the Earth ever falls into a black hole, maybe it would not be death at all. Maybe it would be the universe taking itself home.